This is the chapter 8 part 1 review. So the assignment that I gave you yesterday, I'm gonna go through every single problem, printed it out, that way you can see my work and I'll have to have a separate scratch paper. Here we go. First one, triangles. The interior angles on a triangle, they always add up to 180 degrees. Just a rule, should be a quick point. To use Pythagorean theorem, you have to know the two sides and then you can find a missing side. So unlike SOHCAHTOA, you don't need one angle one side. For Pythagorean theorem, you have to have two, either the legs or the hypotenuse, but you have to have two. For SOHCAHTOA, for trigonometry, that only works on these right triangles. Number 4, this is already being set up, so you're just finishing off the problem. Remember right here, to save yourself some time, the bottom, sorry, if x is on the bottom, that means you're going to divide this. I'm going to go directly into my calculator. So 12.1, because it's always from the fraction first, the number from the fraction. And then because that's on the bottom, divide. And then everything from over here, sine 24. And then that'd be 29.75. So that's D. Over here, you're working out the whole problem, so you still want to find out what do you have. We're going to have to figure out if we have opposite, adjacent, or hypotenuse from the 43 degrees. This one would be the hypotenuse. We don't have that one. This one's right next to the 43, so this one's adjacent. And all the way across, this one's your opposite. Now that we know what we have, opposite and adjacent has to be tangent. The angle always goes next to the tangent. And for the fractions, for SOHCAHTOA, it says opposite goes on top, so A, and adjacent goes to the bottom, 11. This time, our variable's in the numerator, it's on the top. So we're gonna multiply. Take my calculator, we'll go directly into my calculator from there. So the number from the fraction, multiply because A is on top, and then the tangent of 43. And that's 10.257. Ah, I didn't even have to solve it. It says, what would you use? Duh, tangent. I could have saved a bunch of time. Number 6, it says, what are the side lengths? This one I'm going to have to work out. So from the 28, x is opposite, and 14 is adjacent. Again, using that SOHCAHTOA, opposite and adjacent, we're still at tangent. The angle's going to go right here next to it. Opposite on top, adjacent on the bottom. X is on the top, so we're going to multiply. That's enough to get me to my calculator. The number from the fraction, multiply because x is on top, and then everything from here, tangent of 28. And I get 7.44, that's over here, that's C. Next one, from way up here, this is adjacent, and 41 is the hypotenuse, because it's across from the right angle. Even though it's an X, this is just asking for the setup, so you can still do it. Adjacent and hypotenuse, that one's cosine. Adjacent on top, hypotenuse on the bottom. So the angle is going to go here, but since we don't have it, it says it's X, we're going to put X. And then adjacent comes over here on top, and hypotenuse goes down here to the bottom. And the one that looks like that, let's see. Now the second part of chapter 8, I'm going to show you guys how to find the angles with these missing sides. But for right now, We're just working forwards, and we're gonna go in reverse after we do this quiz you're gonna have on Friday. So which trig ratio is correct? Let me get my little notes right here. So for cosine, it's supposed to be adjacent over hypotenuse. Cosine, adjacent, hypotenuse. There it is. If you look at the other ones, tangent was supposed to be opposite over adjacent. That's not opposite over adjacent. Sine is supposed to be opposite over hypotenuse. That's not opposite. Even though that is hypotenuse, that's not opposite. And then tangent is supposed to be opposite over adjacent. This is upside down. It has adjacent first and then opposite on the bottom. That doesn't work. It has to be opposite on top and adjacent on the bottom. Number 9, it says in the accompanying diagram, triangle ABC is a right triangle. So that means even though it's not in the drawing, this is a right angle up here. And CD is the altitude. So because it has an altitude in it, that's how you know this problem is going to be geometric mean. So it's going to be where it's the product and then you square root it. So AD is 4, that's the left side. DB is 16, that's the right side. And then it says find the length of CD, and that's right here in the middle of them. So we're just going to use those pieces the way they are, the 4 and the 16. Putting that into the calculator, I'm going to go 16 times 4. Or if you're really good at multiplying, you already know. That's the square root of 64. And then the square root of 64, if I factor that out, 8 times 8, I already have a pair right there. There aren't any leftovers. I don't have to break it down any further. I already found my answer. I used factoring it out because the answers that were available had square roots in them. So like this one right here, I'm going to do the same thing. Since there's square roots available, I'm going to factor it out instead of doing the decimal answer with the calculator. Same basic setup. In the accompanying diagram, triangle ABC is a right triangle. So this is still a right triangle. CD is the altitude, once again. And then it says AD is 4, so we still got the same number here. DB is 16, same number over there. And then it says find the length of AC. That's the left side. So that's one of the legs. It's not the altitude. We're still using geometric mean. But for the legs, you always want to know what's your hypotenuse all the way across by adding them together. Because it's going to be the geometric mean of the part that's closest and the entire hypotenuse. This is going to be the square root of 80, and I'm going to factor that out. So 80 could be 8 times 10. It's pretty easy to see that because there's a 0 here. 8 is 2 times 4, and 4 is 2 times 2, and 10 is 2 times 5. I have a pair of 2's here. There's another pair of 2's there, and this 5 did not have a pair. So I'd multiply it together. The 2 and the 2 would go on the outside, and then this 5 would be stuck inside. 2 times 2 is 4. So my answer would be A. Number 11, same setup for the third time. So we still have a right triangle. AD is 4 still. DB is 16. But this time we're looking for BC over here on the right. If it's one of the legs, we need to find the hypotenuse all the way across. So add those two together. Geometric mean. And we're going to use the part of it that's the part of the hypotenuse closest to what we're looking for. And the entire hypotenuse. Once again, we're going to factor it out, but this time, since I know I'm going to have to factor it, and all that's going to do is break it back apart, I'm just going to start factoring from here. And I already have one pair. And then over here, 4 times 5. 4 is 2 times 2. There's another pair. The 4 and the 2 are going to go on the outside and multiply together. On the inside of the square root, I'm going to have this lonely 5. So 4 times 2 is 8. And then 8 square root of 5, that's B. Number 12, find the missing side. We have two of them. We're missing the last one. We're only going to have to find one. That's using Pythagorean theorem, that a squared plus b squared equals c squared. A and b have to be the legs, doesn't matter the order. So I'm going to put the 4 squared and then the 5 squared. 4 squared is 16. 5 squared is 25. 16 plus 25. It's 41. And then the answers are in decimal, so this time it's okay to use the calculator. Square root of 41. Now you get 6.4. 6.4 is C. And the reason I square rooted it was to get rid of that square. So square rooting gets rid of the C squared, the squared part. But you have to be fair, and that's why we're doing it on both sides. 13 is another Pythagorean theorem problem. Remember, the legs are the ones that are the A and the B. Hypotenuse has to be the C. 15 squared, B squared, 25 squared. 15 squared is 225. 25 squared is 625. You need to move this 225 across that equal sign, so it's positive. You're going to subtract it and be fair. B squared equals, I think that's 400. Yep, 400. And then remember, we're square rooting it. The answer here is decimal. There's no radical in the answers, which means the calculator is going to work just fine. Square root 400. I got 20. Nice. So there's 13. Number 14 is asking, do the segment lengths 9, 15, and 12 form a right triangle? So that's using the Pythagorean theorem, but in reverse. So it's going to be the converse of the Pythagorean theorem. This a squared plus b squared equals c squared. Remember, the hypotenuse goes over here. That means the longest out of those three sides has to be by itself. The 9 and the 12 go together, and the 15 goes by itself. 9 squared is 81. 12 squared is 144. 15 squared is 225. If you add these two together, it's exactly the same as 225. That makes it true. So yes. 15, same question, is it a right triangle? So same process. The longest one is 26, so that's the one we're going to pretend is our C. 10 squared, 24 squared, those are the ones we're going to treat like the legs. And then 26 squared, 10 squared is 100, 24 squared is 576, 26 squared, 676. If we add these two together, it's exactly the same. So that's true. That also makes a right triangle. 16. We're back to trigonometry, the SOHCAHTOA. From this angle, we have two options, but I'm gonna pretend this one's not here. From this angle, that's adjacent, and y is the hypotenuse. And adjacent and hypotenuse, if I'm using this instead of that special right triangle rules, adjacent and hypotenuse goes to cosine. And then the angle goes right next to it. I chose to use 30, so I'm going to put that next to it. Adjacent goes to the top. Hypotenuse goes down to the bottom. This one I'm dividing because y is on the bottom. In the calculator, This is going to get tricky because of that square root. Another reason why knowing those special right triangle rules helps. So 4, wait. First is supposed to be, yeah, the number from here. So just in case something weird happens, I'm going to put parentheses around 4 square root of 3. That's going to be my number that comes from the fraction. And then divide, because the variable's on the bottom. And then cosine 30. And then you get 8. If you see the shortcut, because this is a 30, 60, 90 triangle, the rule on a 30, 60, 90 is always find the short side first. And from here, you multiply to get to the long leg. But if you're going in reverse, you're going to divide by the square root of 3. And this side is 4. And once you know this side is 4, the short side times 2 will get you to the hypotenuse. That still gives you 8. So either way works. So if I want to use the special right triangle rule, these two sides are the same on a 45, 45, 90. And then the hypotenuse is the leg times the square root of 2. So if I get this 11 square root of 2 and I divide it by the square root of 2, y is 11. That's pretty quick compared to the long way, which is using the SOHCAHTOA and going, okay, let's pretend this one was in here, and this would be my adjacent, and this would be my hypotenuse, and I'm using cosine of the angle. Adjacent goes to the top, hypotenuse goes to the bottom, and then putting it into my calculator. I still gotta be careful because that's not a nice number. So I'm gonna put parentheses around my 11 square root of 2. That's my number that comes from the fraction. This time y is on top, so I'm gonna multiply. And then the cosine of 45 goes at the end. I still get the same answer. It's actually trickier, in my opinion. Here's another special right triangle. If you remember the rules for the special right triangles, it goes like this. Boom, boom, boom. 60, 30. The short side's the most important one. The long leg is the short leg times the square root of 3. And from the short leg to the hypotenuse, it's just twice as big. So if you remember the pattern for the 30, 60, 90 triangle, because it is special, and you go, okay, that hypotenuse is twice as big as what I want, and you just go 36 divided by 2. You get to 18. If not, then you're using that SOHCAHTOA, the trigonometry, then you're pretending that one of these angles isn't even here. And then this would be the adjacent if I went from the 60, and 36 would be the hypotenuse, and adjacent and hypotenuse would be cosine. I'm using the angle 60. Adjacent says x goes on top, hypotenuse goes down here at the bottom. This is multiplying, so I would go 30 times the cosine of 60. But when I put it in my calculator, I still get 18. Another special right triangle. So I'm only worried about x, so I don't care about y at all. This is adjacent. This is hypotenuse. There is a shorter way, but adjacent and hypotenuse is cosine. Cosine says adjacent goes to the top and hypotenuse goes to the bottom. And I put it into my calculator like 4 divided by, since the x is on the bottom, cosine of 45. Putting that in the calculator, I'm going to get a decimal. 4 divided by cosine 45. I'm gonna write it down. 5.6568 blah 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 blah. I'm gonna go 4 spaces since I'm going with the calculator, and the answer over here has a square root of 2 and this one has a square root of 3, and it's kind of close. Then I have to do a conversion and go, I know it's this one. It's gonna be 4 square root of 2 because of the special right triangle. But I'd have to do a conversion and I'd have to go, what is this as a decimal? 4 square root of 2. 5.65, and I have to compare it. 5.658, yep, that's the one. If I would have guessed this one first, I would have put this in the calculator. 4 square root of 3. 6.928, and I'd compare it. Nope, that's not the same. That's how I know it's not this one. But if you can remember those special right triangle rules, it will be much faster and much easier once you memorize or understand them, and you can use your notes when you're doing these problems. This is another special right triangle. I'm going to go ahead and do it with the special right triangle rules. And those say that from the hypotenuse to the short leg, this is supposed to be twice as big as this one. So I know this is just 2 square root of 3. I just cut the 4 in half. The question's asking for m though, and the rule for the short leg to the long leg was on a 30, 60, 90, you multiply by the square root of 3. And I'd go 2 square root of 3 is supposed to get multiplied by a square root of 3. Now I have a pair of them. 2 times 3 is 6. And I'm done. If you do it the other way, you're going to go from this 30-degree angle. That's the hypotenuse. And this is adjacent. And then you come over here to cosine, adjacent and hypotenuse. And then you put the angle next to it. Cosine says adjacent goes on top, hypotenuse goes on the bottom. This is going to be multiplication. And then in the calculator, you're going to put the number first. Remember, I highly recommend you put those parentheses because it is kind of an ugly number. Variable is on top, so you put multiply after that, and then cosine of 30. And it's going to get you the same exact answer. But you have to be more careful because that 4 square root of 3 makes it a little bit tricky.